Last chapter we learned the Pythagorean identities. You get sine squared of theta plus cosine squared of theta, you get 1. If you divide them all by cosine squared theta, you get our second identity, tangent squared of theta plus 1 equals secant squared of theta. If you had divided the original by sine squared theta, you'll get 1 plus the cotangent squared theta equals the cosecant squared of theta. So we've done one similar to this last chapter. We're going to express tangent in terms of sine, where theta lies in quadrant 2. So we want tangent in terms of sine. Tangent of theta is really sine theta over cosine theta. So that means we need cosine to be in terms of sine. So we need to work with our first identity, and we need to get cosine theta alone. So we now plug in the square root of 1 minus sine squared theta for cosine. So you get sine theta over the square root of 1 minus sine squared theta. So then we now need to look that it's in quadrant 2. We are originally taking the tangent. Tangent is not positive in quadrant 2, so we need to make it negative. We're not going to worry about rationalizing this denominator. We can leave it as is. So tangent theta equals sine theta over the negative square root of 1 minus sine squared theta. Our next example is if tangent of theta equals 2/3 and theta is in quadrant 3, we want to find the cosine of theta. So our goal is to get everything in terms of cosine. So then we have to look at the identity that has tangent, and that identity is tangent squared theta plus 1 equals secant squared theta. Tangent is sine over cosine. That's kind of difficult just to get cosine along, but secant is 1 over the cosine. So this is really 1 over cosine squared theta. We want to get just secant, so we need to take the square root. So to get secant, instead of secant squared, take the square root of both sides. Secant theta equals plus or minus the square root of tangent squared theta plus 1. But secant squared theta is 1 over the cosine. I just want cosine, so that means we have to flip around this equation and you get the cosine of theta to be 1 over secant theta. So 1 over plus or minus the square root of tangent squared theta plus 1. In quadrant 3, it's negative, so we can go ahead and cross out the positive. So this is where the tangent of theta, being 2/3, comes into play. We take that 2/3 and we plug it in for tangent. So the cosine of theta equals 1 over the negative square root of 2/3 squared plus 1. 2/3 squared is 4/3 plus 1. 4/9 plus 1 is 13/9. So you're at 1 over the negative square root of 13/9. You can take the square root of the 9, so it gives you the negative square root of 13 over 3 in the denominator. And now it can't have a fraction within a fraction, so you flip it. You get negative 3 root 13, and you can rationalize it and get negative 3 root 13 over 3. So if secant of theta is 2, and theta is in quadrant 4, we want to find the other 5 trigonometric functions of theta. So we need to make a triangle. So we have our triangle, it's a right triangle, we have theta, and we know that secant of theta is 2. We know that secant is 1 over the cosine. And we know that cosine is the adjacent over the hypotenuse. So we can't have a fraction within a fraction, so we flip the bottom one and get h over a equals 2. So we're going to assume that a is 1 for the denominator and h is 2. Using the Pythagorean theorem, 1 squared plus opposite squared equals 2 squared, so 2 squared is 4, minus the 1, square root it, that gives you root 3, using Pythagorean theorem. So we now have our triangle. We don't need to know the angle of theta and the third angle, so we can just start filling in the sine of theta being root 3 over 2, but we're in quadrant 4, So the cosine and the secant are positive. Everything else is negative. So make it a negative root 3 over 2. So then the cosecant of theta is going to be the reciprocal, negative 2 over root 3. Rationalize that denominator, negative 2 root 3 over 3. Cosine is going to be positive 1/2. So then the secant of theta is 2, which was given to us, so therefore we are doing it right. The tangent is the sine over the cosine. It goes to negative root 3. And then the cotangent is the reciprocal of the tangent, so negative 1 over root 3, which is negative root 3 over 3. When you have an area of a triangle, when using our trigonometric functions, we have area A, side lengths A and B, and with included angle theta, you have the formula A equals 1/2 AB times sine of theta. So you can use this formula even if you don't have a right triangle, or you don't have a perpendicular bisector to give you a height to a base. So we have our given triangle ABC. We have two side lengths, 10 and 3, so A and B. And then we have theta being 120. So we can plug it into our formula. A equals 1/2 AB sine theta. So A equals 1/2 times 10 times 3 times the sine of 120. 1/2 times 10, that's 5, times 3 is 15. And you find that the sine of 120, using the methods we did by finding the reference angle, is going to be 60 as your reference angle, 60 degrees. It's in quadrant 2. Sine is positive in quadrant 2. We need a positive area, so that works. 15 times root 3 over 2 gives us roughly 13 centimeters squared.